Hey guys, so this is going to be a quick applications of derivatives in the power rule lesson. You're going to see derivatives all over calculus, and they're going to get more and more complicated, but I want to just quickly introduce really one of the ways they're frequently used, as well as one of the ways you actually calculate derivatives, right? So real quick, let's give an example. Let's say you're looking at the function y equals x squared, right? Looks like this, and someone was like, hey, at x equals 1, I want to know what the slope is, right? Sorry, you can't really tell with the marker, but I want to know what the slope at x equals 1 is. And you're like, well, it's rise over run, but I actually don't know rise over run because it's not a flat function, right? So this is the first way that, or one of the ways you can use derivatives, right, is basically in calculating slopes, right? So that is the premise of one way you can use this. Now let's quickly take an aside of alright, the power rule, right? So if I have a function that is y equals x squared and I want to take the derivative of it, let's actually call this y for the time being. What this looks like, and we'll get into the details of what the syntax are, but just quickly how to do it. You'd say, oh, the d over dx, right? I'm taking the derivative with respect to x of this, and again, this I don't expect this to make entirely a lot of sense, but let's go through the mechanics, and as we do it more and more, it'll make more and more sense. I want to take the derivative of y, and I want to see what I get. So I'm like, a lot of times people will call it d dx, a lot of times people will just call it y prime, and what you'll do is you will take this and you will move the number that's up here down here, and you'll subtract it by 1. So you'll take the 2 will come down, you have the x, and then it is 2 minus 1. So effectively the derivative of this function is 2x, right? That is what you just did. You just took the derivative. Another real quick example is if I had y equals x cubed, what would I do here to find the derivative? Again, all of this is just syntax, but to do it, I would take the 3 down. Actually, sorry, I'll call it y prime. I'll take the 3 down, and I have 3 in front of x. Oh, okay, I gotta take the 3 minus 1. So I have 3x to the 2. Right? So these are, you just did 2 derivative problems, right? These are really basic, they'll get more complicated, but that's what it is. So back to the problem, right? If I'm looking at this and I want to find the slope at this point, what you can do is say, okay, this is the function f of x. To get the slope, I would take the derivative of this, which we already did. So we said, hey, f prime of x equals, bring the 2 down, x 2 minus 1. Okay, and now the question was, at x equals 0, what is the slope? So if I were to plug in at x equals 1, what is the slope? And you'd find out that the slope equals, okay, I'm going to plug in that 1 that was here into the x, and I'm going to get 2, right? Great. So the slope at this point is 2, which is pretty neat, right? So this will help you do a lot of problems. Again, I intentionally swap between syntax here, between this and this. These are all just saying the derivative of that function. And again, you're going to see a ton of this stuff, so you may as well get used to it, but that is a quick introduction.